You type a question and press enter. In the next second, something happens inside a machine. Nobody can fully explain it. Not the people who built it either. They can tell you exactly what the machine does. They cannot tell you why it does it. That is not a figure of speech. It is the precise technical description of the problem. And it sits in your pocket right now. So let us follow one single sentence through the whole machine, all the way through, from the moment you type it until an answer appears. The very first thing that happens to it is a cut. Your sentence gets chopped into small pieces. Not into words though. Into fragments the machine calls tokens. Sometimes that is a whole word. Very often just a piece of one. Why cut words apart at all? Because a machine needs a fixed inventory. It cannot invent new pieces later. That inventory holds around 120,000 pieces. Every text it reads is built from those. Every text it writes, too. Common words get one piece to themselves. Rarer words are broken up. A name you just invented might take 5. This is already a decision with consequences. The machine never sees your sentence. It only ever sees the pieces. And the pieces carry no meaning yet. They are just entries in a list. Position 4000 and something. Meaning has to be added from outside. That is the next step in the chain, and it is where things get strange. Because a machine cannot store meaning as meaning, it can only store numbers. So, meaning has to become a number. Every single piece becomes a long list of numbers. Not one number, not a handful, several thousand of them. Think of it as a position in space. Not a space you could ever picture in your head, one with thousands of separate directions. Pieces that behave alike end up near each other. Nobody placed them there. The positions came out of the training. That is worth pausing on. The arrangement was not designed. It emerged from reading enormous amounts of text. But position alone is not enough. The machine still has no idea about order, and order changes everything. The dog bit the man bit the dog. Exactly the same pieces, a completely different sentence. So a second number is added to every piece, one that says where it sits. Without it, order would not exist. So now every piece knows two completely separate things, roughly what it means on its own, and exactly where it stands in the sentence. What it still does not know is anything about the others. Each piece sits alone. That is the next problem. Because words do not mean things on their own. Bank means one thing beside river, something else beside money. So the pieces have to look at each other, all of them, all at once, and that one mechanism is the whole trick of it. So here is what each piece actually does. It asks a question of the others, and every other piece answers it. The question is not made of words at all. It is simply another long list of numbers, but it behaves exactly like a question would. Every other piece holds up an answer. The two get compared. The closer they match, the more weight it gets. So a piece does not treat all its neighbors equally. It leans toward the ones that matter. That is attention. In our sentence, the word bank looks around itself. It finds the word river nearby, and it shifts its own meaning accordingly. Nobody wrote a rule for that. There is no lookup table for ambiguous words. The weighting came out of training. And this does not happen only once per layer. It runs many times in parallel, each pass looking for something different. One pass might track who did what to whom. Another might track tense or number. Nobody assigned them those jobs. Researchers work these out afterwards by probing the finished model. Some passes stay unexplained. That is normal, not alarming. After all this, every piece has been rewritten. It now carries something of its neighbors. It is no longer alone. And then the whole thing runs again. Same mechanism, new starting point. On the rewritten pieces this time. How many times? Depending on the model, between 30 and over 100. Each layer on top of the last. Picture that stack for a moment. Dozens of flaws, each one rewriting your sentence, each one handing it upward. The lowest flaws deal with surface detail, word shapes, simple grammar, nothing more. Nothing you would call understanding. Higher up it gets harder to describe. Relationships, roles, something like context. The vocabulary runs out quickly. Somewhere in the middle sits a researcher with a probe, trying to work out what one single layer is doing. It can take months. This is the part that gets called a black box. Not because it is hidden. The weights are right there, readable. You can read every single number inside the model, every one of them. That still does not tell you why it answered the way it did. It is a bit like reading every neuron in a brain. True in principle, useless for predicting the next sentence. And that comparison is exactly where people go wrong. It is not a brain, in any sense. It shares almost nothing with one. What it shares is only this. Both are systems whose behavior we can observe, and whose inner workings we describe badly. Meanwhile, our sentence has reached the very top floor, rewritten dozens of times along the way, and now something finally has to come out. What comes out is not an answer at all. It is a list, one number for every single piece in the entire inventory. 120,000 numbers all at once, each one of them a probability. How likely is this piece the next? Almost all of them sit near zero. Only a handful stand out at all, and exactly one gets chosen. Not always the highest one, by the way. A little randomness is deliberately allowed in, otherwise the machine would sound mechanical. Then that one piece gets added to the end of the sentence, and the whole process starts over again, from the very beginning. Cut, weigh, rewrite, predict, for every single piece it produces, dozens of times per sentence. Which means it never plans a sentence. It has no idea how the answer ends, not while it is writing it. Every word it writes changes what comes next. The sentence builds itself forward, one piece at a time. And this is the point where the whole thing gets misunderstood. Because it sounds like thinking. It reads like thinking. The machine was trained toward exactly one goal: produce a plausible continuation of the text, not a true one. It treats a sentence about physics exactly like one about unicorns. Both are only patterns of pieces. Truth is not in the calculation. Somewhere right now, a model is inventing a source that never existed, complete with author and year, and it sounds entirely convincing. That is not a bug in the system anywhere. It is a property of the system itself, and it starts with the very sentence you typed. If you want the next one, subscribe, and tell me in the comments below, which system should I open up next?